have to define a notification message of some sort, or we have to pull it, one or the other.
Any other Q&A from the team here?
The typical internal HA involves something like, for example, end of rep notification from a given protocol that it has finished forming, basically processing all the entries into router, just as an example. So in terms of flows, I guess, to mark itself ready, something similar could be used. Just wondering if that is documented. And I guess if not, then that is something we will need to do. And if there are any, if there is anything related to operational state that is already documented in the HA document that Marianne has, we could look at that. Christina?
Mm-hmm. Marianne, do we have a copy of the document to place into the GitHub?
Again, which document?
Reshma, which document?
Any HA document where we have recorded the operational states, like Marianne mentioned earlier, that it is recorded?
Oh, it's in the SCI API.
Oh, okay, in the API.
In the experimental branch? Or experimental folder, I'm sorry.
Yeah.
So that's what I'm displaying right here. I can.
No, it's not yet merged.
What's that? Or not yet merged?
Not yet merged. It was supposed to be reverted by Prince, and then I will upload my version. I didn't check up with him if he reverted that or not.
I think Prince is on the call.
As I said at the beginning of the call, I will send a link to my pull request after I get back home, because I'm not yet there.
Okay. So any other general QA for HA before we end this session then?
So there was discussion about resurrecting the topic of what to exchange and stuff like that. So is that going to be formally specified as part of the Dash specification? What will be exchanged? Is it the packets or the just the metadata and stuff like that, or is that just a recommendation?
Yes, and to add to that, TCP states at all, do we want to sync anything related to that?
Yeah,
are you talking about
that left to the vendors, or
are you talking about the messages that go back and forth to sync this the connections?
Yes.
Yes.
I think will be the next topic. We have some different ideas. I know Pensando has, one idea, and that they're even, trying to optimize it right now to use less messaging potentially. And then there's another idea that says we don't send packets from one to the other in order for the secondary to, basically do the same thing. Look at the packet, bring it through slow path, make a connection entry, do everything that the primary did. Like, so the alternate proposal is to say, no, the primary has already done that work, and its job is to send the state across, and the secondary just basically copies the state into its connection table, for example. So there's many ways to optimize where you don't have to send and redo work, or at least not as much work. And so that's I think that's why I've always said that, and I don't know how much Pensando's going to disclose, but if they're going to disclose how they do theirs today, then would be mode 1. And I think mode 1 is where you really do use the methodology of sending, the SYN packet all the way to the secondary and potentially back again before it goes out. That's mode 1, in that it preserves basically the packets, and you're relying on the fact that a secondary is doing exactly the same thing that the primary would do in building up the connection table. I think that's like mode 1. And so we can actually ask Pensando formally and how much they're willing to disclose as far as that to the community. If not, we can make it up ourselves. And then I think Excite really was working on 2 things. One was, and I think they're separate, by the way. One was, should the protocol be reliable or not? And the second was, how can we make the messaging to the secondary more efficient through and not have it do all the same things that the primary already did. Like, for example, determine the state of the TCP state's already been done. Do we really redo that, or do we just send the state? So I think there's some debate over that, and so even if we don't agree on the exact messaging, I think we need to discuss the different approaches, and the reason we need to discuss it is some approaches are much more efficient than others. They use a lot more bandwidth, less packets, and less processing. And so it's important to have the discussion. And so I don't know if anybody's from, so I think the first one is, if Pensando's on the line, and I'm not asking them to disclose anything now, we have to decide, are you going to disclose the packet sequence that you were thinking about to maintain state? If not, then the community here will have to reinvent that, basically. And so that would be the first question. If they're willing to disclose the sequence that they're thinking about, then I think we can go over that and call it mode 1, and then just kind of go over it and agree that that would be a methodology, and that everybody can kind of see and know that that'd be one methodology that would work. And then if we can get through that, then we go to mode 2, which is like defining a more efficient one, which, like I say, transfer state as opposed to makes the secondary recalculate it, and secondary being a little bit more blind to what's going on, just maintaining a table and transferring state into the table as a slave, as opposed to recalculating everything. So I prefer to talk about mode 1 first. Is Pensando even on the line? Is there anybody from Pensando?
Yeah.
Can we get Pensando's opinion? Are you going to disclose the sequence of HA that you're doing today or not? If no, then we need to reinvent it.
Yeah, Jerome. So I don't have an answer for that yet. So I'll have to go back and discuss with the team. But yeah, so my question basically was, because I was under the impression from listening to the earlier recordings that the actual implementation of how it's done will be left to the user, left to the vendors.
No, we just stopped the discussions. We didn't say that, because there's too much arguing over the, mode 1, mode 2, mode 3, who's reliable, unreliable, and then, so I did make it clear that this is a very important point, that if we go down the road and we say, no, everybody just do whatever you want, first of all, it makes it really difficult to test. And secondly, there's going to be a bunch of losers here, because whoever comes up with the most efficient approach is obviously going to have a serious business benefit. And so if that's what everybody wants to do, then there's going to be one winner here, and everybody else is going to cry. So I don't agree with that approach.
Okay. Yeah, because I thought I heard something about the inter-vendor need not be there need not be interoperation between vendors and so on. So
I think this decision for later on, the practicality of getting the approach exactly the same across vendors. I think we'll have to discuss that later. I think the first thing is to document the approaches that are reasonable that can be taken and compare the efficiencies of each. And
So-
that way we don't have people running off doing a very inefficient design, trying to comply only to find out that they can never get business.
Okay,
And
got it.
I gave some examples of like how bad this can get, right? If we actually were to take the simplest approach, but very reliable, we would send every packet back and forth that was involved with the connection tracking to the secondary. That would be the simplest approach, and we would just duplicate everything. But at, let's say, 5 million connections per second, going back and forth, you can just imagine it's 5 million times 6. And then you have to multiply that by 2 if you're going to actually reverse, send those packets back. You are literally taking up the entire user data path. So I think that's why this deserves discussion, that even its simplest approach can be optimized.
Right.
You can optimize the tail, for example. Do you really need to send all the states, the packets across or not? And what is the result? Just simple investigation of, worst case, a connection is held open too long. Well, that's a lot better than a connection that closes prematurely. A connection that closes prematurely can actually cause the connection at the endpoints to basically go haywire and really just, they can't talk to each other anymore. They can't send closes, they can't send resets, they can't send anything. So we can go through as you go through the state machine, like what is the most optimal way, what really needs to go across, what doesn't, what can be assumed by the other side. If you want to err on keeping things open versus closing prematurely, that obviously gives you a little bit of leeway. I've documented a few things, like when you do a sync, no matter how you do it, when you go to the secondary, you got to resimulate all the connections anyways. Like, so anything that shouldn't be there anymore due to policy updates that happen kind of in play, you have to resimulate. And so you're going to get rid of all the connections that shouldn't be there. That way, so the result will be you have some maybe open connections that didn't receive a FIN, and what do you do with them? But the reality is, I think we can get even what I call mode 1, where you're sending packets across. We can optimize that, I think. I don't think we need to send so many packets back and forth.
Gerald, this is John Carney from Excite. So what we had proposed, and it's it's documented, people can read it, is like a framework for allowing like several different modes without even having to define what those modes are up front. Basically, the ability for the sender to send either the packet, the original packet, or some digested form of the packet, and defining that the receiver has like an invariant logic that it has to perform. And then it really becomes up to the sender to decide, does it want to send the packet? Does it want to send a message? Does it need a reply back? Does it not need a reply back? And if you build on top of this, you can get to like, increasing levels of like optimal, HA, but it does it, and it allows for interoperability, and it doesn't require like everyone to have to do the most optimal solution to be interoperable. And so like I would encourage people to read it, because I don't.
John? Am I showing
Yeah,
the right again?
Yes.
Okay,
Yes.
great.
And
Yeah,
I would encourage people to read it, because I think it's like consistent with what you're saying, Gerald, and in a way that allows for innovation, and interoperability.
Yeah, that sounds excellent. I think if people have, I did not read this one. I like it. I like the idea, especially that it would support all the different modes. And I think even mixed mode is possible, by
Right.
the way. I think
That's
you can
right.
send the first packet and say, because that has the most information that I need, and then send messages after that, just transferring state or whatever.
Absolutely.
Yeah.
It would allow that. It would also allow like you to make a decision to say, well, for certain state transitions, you know, I'm going to send those immediately. For other ones, I'm going to send those periodically. Like it really becomes like the decision of the sender to decide like how advanced it wants to be in the synchronization of state. And the receiver just performs a very simple function. The receiver just accepts the state and updates its local state and either sends a response if requested or not. And so like I think people should read it. It's not pushing a particular mode, like you say mode 1 or advanced modes. It's not pushing a particular mode. It's a framework that allows lots of different modes to be implemented while still remaining interoperable.
Agnostic, yeah.
Now, does it allow for, I think it does, but I'm just going to pose one question because I think a lot of times the receiver shouldn't process anything, should just take the state receiving and copy it into its connection table and hence forego all, all computations other than writing that state into the connection table. Does it allow for that?
Yes, it does. So it basically the receiver receives either a packet or a message. And in the case that the receiver receives a message, then that message is just the current state of a connection, and it updates its table with that current state.
Blindly, yeah, that's okay. That's good.
And it's up to the sender to decide whether the sender wanted to send the packet or whether the sender wanted to send the message. And then the sender also decides whether it wants a response. And the response could be the entire message comes back as a response. Like in your mode 1, for example, the entire packet can come back as a response. Or you could get a truncated version of that back. Or the sender could even send some opaque information, and that opaque information comes back. Like I'll give you another example, Gerald. And maybe nobody would ever implement this, but maybe the sender actually buffers the packets locally and just sends a message, but it still wants a response back before it then sends the original packet to the network. So rather than sending the packet and getting the packet back, it just sends a message and gets an acknowledgement back. And all of those approaches are possible with what's being proposed. So, like I think there was a period where, there was like, let's just say conflicting opinions between like NVIDIA and Excite about like, what's the right approach? Should it be reliable? Should it not be reliable? And so this proposal is really an attempt to embrace all of those approaches while still being interoperable.
Yeah, I really love it. I'd like to read it until I read it. I can't know for sure, but it sounds awesome. I guess if it's easy to formulate the message from all the technologies that we're talking about. How about other people on the call? What do other people think of that just in general? And we'll all go off and read it in detail. Is it anybody else have an opinion on that?
Yeah, just to throw out there a little bit, John and Gerald, right? I mean, we can go down to the weeds with various modes and combinations here, right? To throw one more curveball or maybe a half break idea that I have, at least that I'm thinking aloud as I'm making some sense here, is there a way for a notion for a centralized database wherein all the engines just push it to a database and the listeners on that database will actually be the ones actually synchronizing, right? So that way it's a little bit more flexible and
but we're talking about millions and millions of connections per second. We can't be
Correct.
You cannot send to a database. It can't be retrieved fast enough. We're talking about stuff that's churning at a rate of 5 million, 10 million,
So
20 million
local to
connections
the-
per second.
But
Yeah.
where it'll help is it's instead of a peer-to-peer one-to-one, it can do a one-to-many. Or
If
you
it's
can,
just not fast enough, you can't retrieve things from a database and in the millions of connections per second like this.
okay. I mean, because if it's an end-to-end redundancy or the models that you want to develop further, right, then the order of messages at the scale will just be overwhelming in any ways. So you can reduce that at scales of clustered operation, the database.
Yeah, I think that's more of a database synchronization kind of thing. But in this particular scenario, unless you can explain how you would keep up to 5 million connections per second or so, I don't think that's not the technique we're thinking about here.
Okay.
Yeah, and I think I think that there's also like a case that you could make for like you have to in some cases, depending on how much, and I'll use the word fault tolerance. And what I mean by fault tolerance is that in the event of a failure, like do you lose connections or not lose connections? Like if you can't tolerate like any loss of let's just say, and maybe every deployment is different, but let's just say that there's a deployment that says, for established connections, I cannot tolerate a single loss of a connection. I can't black hole any single connection. Well, then, like in that case, I think the conclusion is that an acknowledgement, has to be sent from the receiver of the state synchronization back to the sender, so that the sender is aware that the receiver is in sync. And I think that this idea of like publishing it to a database or something like I think that you need like in some cases the sender needs like a positive acknowledgement that the receiver is in sync. And I just don't know how to do that other than to have like a direct protocol between the sender and the receiver.
Yeah, the Cartesian product of the senders and receivers with messaging can just get too many. So the database actually does some dampening of that effort. And if you have multiple classes of connection across these 5 million, like you're espousing, you're saying some that can not afford to lose messages, some that can, then you're only synchronizing what you really need to, as opposed to everything.
I think the data, like the centralized database, is adding like another component that's just as expensive or even more expensive than the clients of the database, right? So I think it's just like a very costly solution to add like a third entity
Right.
in the HA.
Right. There are in certain scenarios like the UPF, that they're able to subsume that cost, and yes, there's other cost to it, development and footprint and things like that. But certain applications are okay with stuff like that in the scenario of the user planes.
Yeah,
actually I have one comment. Sorry, this is Suresh from Broadcom. The other Suresh, somewhat related to Murali's question. So, are we only thinking about one-to-one? Is there a need for a one-to-many?
Right. That's
model at all.
Seems to be one-to-one, at least in the models that are proposed right now.
I think we have to start with one-to-one, and we're going to implement one-to-one. Would it be advantageous to have a 2-to-1? Of course, but I don't know if we can start there. We could have discussions on it though, but I think we need to resolve one-to-one initially.
Is there current implementations in like Pensando or other where they've done a one-to-one or one-to-many, and where are they looking at? Where are we? I mean, in the market today?
Today we're one-to-one, and we're not. It's not a primary secondary, by the way. Like it's both are secondaries to each other, so both are active. So both have.
It's a one-to-one active to active.
Yeah,
Thanks.
so they're both active and they're both backing up the other device one-to-one, but it's not active standby, it's active.
Yeah, in the connection tracking scenario, you want to have active because you want to be able to fast reload.
Oh, we just get, when they're active, we get twice the capacity from a bandwidth point of view.
Yeah,
So we want to look at that, right? You might get the same connection rate, but you get twice the bandwidth when you're active. So we prefer that. Because 99.99% of the time you have twice the bandwidth.
Right. You can play games with end-to-end actives in a clustered model and things like that. So for that, solutions will have to evolve from where we are from one-to-one that I see right now.
So when we talk about HA, we're talking about I'll give you an example. 2 DPUs, we'll call them DPUs, backing each other up, right? We're not saying, in fact, we've written about this, that a ENI exists on a single DPU, right? You can spray ENI connections across multiple DPUs. And if it arrives on multiple DPUs deterministically, then you can actually have each one of those DPUs backing up that fraction of connections to the others. So we do have coverage, at least for this scenario, where we don't have just a 1-for-1, but it's actually that ENI can exist across many DPUs, but the decision for which DPU the connections arrive is really from the source, right? The source is eCMPing across multiple DPUs, and then each of those DPUs just has the same policy and processes some fraction of the connections. So we do have that. So I guess 1-for-1 active is not everything. We do also have the load spreading ability with this technique.
Yeah. Got it.
There's a cost to it because that means you have to have a policy on each DPU for that ENI, but the bulk of the memory is used by connection table anyways. So we just find that it is a useful technique for spreading.
Thanks, Gerald. Anyone else, guys?
One last question is, are these goals specified somewhere, like no drops after sync, or like for new connections and things like that, or bandwidth being used for the sync? Are these going to be listed out?
I can tell you in the document I wrote, I tried to enumerate out what I thought the goals were without quantifying them. Because
Okay.
I think like for each deployment, it's like each provider might quantify those differently. And so, I don't think like it should be part of Dash to like quantify that, for example, you have to have like 100% reliability of every single connection. I think someone who's deploying Dash can quantify that, because I think that there's like a wide range of possible HA modes. Like Gerald talked about mode 1, but there might be other modes that are like that are, let's say, looser modes that might be perfectly acceptable for like some deployment. So I tried to like enumerate like a set of metrics for HA without quantifying them as requirements.
Right.
Oh,
You're correct. And by the way, I just want to reiterate to everybody, it doesn't matter who says you can't lose a connection. That is not even physically possible. You could have lost a SYN, right? You can't get it back. That means you didn't create the connection. So there's always a moment in time where it's possible that one side goes dead, the primary, and it doesn't send out the SYN, even though it received it. And so you're going to lose that connection, or you lose it in this transition from primary to secondary, because it's not planned, it's an unplanned. And during that, it is always possible that you may not have formed a connection. So we want to like error on, we want to have all the connections that were established stay open. We don't want to lose any connection in the transition that was already open.
Yeah.
But we can't ever say that it's impossible to lose something that was lost, right? You can't go back in time. And
Right, but
you don't know what the failure was. And so what I'm saying is, I'm agreeing with you, John, that
yeah,
your protocol actually accommodates for that. It can be, you can choose. You can choose not to get an ACK and say, look, I know my network doesn't lose packets, which is mostly the case in our case too.
Yep.
I'm going to accept that these connections were formed because they're happening at 5 million per second, right? It's hard to, there's 5 million of them happening in that second. So the likelihood is maybe, there will be a small fraction lost. But I think that your protocol actually allows for either.
right. It allows for you to be as loose or as strict as
Yes.
you want, right? And it's up to the sender to decide how strict it wants to be. And the receiver is just, the receiver is just getting the updates and updating it his state. And then, so I think people should read it. I think that it's a framework that allows sort of incremental improvement in optimization without having to change like the wire protocol. Like the wire protocol can be defined up front, and then more and more complex or loose or different kinds of HA approaches can be layered on top of it and still remain interoperable.
I like it. Let's all at least agree to read it and be open to it. And if after reading it you have concerns, like because you've read it and you've read the details, then we could in the next meeting, Christina, talk about concerns over it. I mean, theoretically, it sounds very good, right? A good place to start, because we're going to argue. Everybody's going to argue that their mode is better for a long time, but if it accommodates what could be, everybody's arguments for the different modes, and that's great. We've got something done, and we have interoperability, and now it's just a matter of efficiencies.
Right.
Yeah.
Right.
So to close off the call, then, can we all agree that yes, we have this link, and yes, we'll read it, and yes, we'll bring our concerns to the table next week?
Sure.
Everyone?
And
okay.
Please
So
don't bring concerns if you don't read it, though.
Yeah, I feel like I present a lot of the same documentation over and over.
So I had one question. So this is with regard to the HA SAI APIs. If we notice something missing or some gaps in the HA SAI APIs, can we go ahead and propose some changes if required?
Marian, would that
Yes,
work
of
for
course.
you? Okay, great.
Yeah.
Awesome.
Okay,
That would be
thanks.
great of you, BJ. Thank you so much for offering. So, okay, then I think we have something to do for the next call then. And then we would also have PRs to look at if there happens to be something in the APIs. So thank you. Is there anything else for today then? Okay. So everyone has the link. Let's read it again. I've read it a few times, but I'll read it again before the next call as well. Thank you, everyone.
Thanks.
Yeah, y'all have